Okay guys, in this video we're going to quickly recap how we graph points in the polar coordinate system as opposed to the rectangular coordinate system. And so just really quickly here, let's reimagine how we think about the way we graph points here. And that is to say that typically when we're given a point here, we're given a coordinate pair and we say x and y here. And what that x and y kind of indicates is how far right and how far up I have to go to get to this point. In this case, go right and up. We could be anywhere in the coordinate plane. But that being said, what I want you to understand is that it might be a little bit more natural to talk about the location of a point as being kind of like how far away it is from the origin here. And so in the past, we've kind of designate this letter R as representing the distance from this point back to the origin here, but also just like what direction we're heading in here. And so you can see that this presents us with our very common x, y, r right triangle situation where we have this point x, y on the terminal side. And so the idea is going to be this. Instead of talking about how we get to points by going left and right and up and down, what we're really going to be doing is really re-representing these points. Let's say I choose the same point here that I chose over here. I would really represent this instead as r and theta. That being said, r and theta really represent how far away from the origin we are and how far of an angle we're rotating from what we say is 0 degrees right here. And so something is to be said about our r and our theta here, and so I'm going to make sure that I write those down here. But we want to acknowledge some things. I suppose that r is the positive distance. Let's see, is it not typing for me here? Let's try again here. There we go. R is the positive distance from the point, let's say x, y, to the origin. Okay, and then the other thing we want to acknowledge here is this. Theta is the direction angle for the point. And so all points are given in the r theta form. When we talk about the polar coordinate system, I suppose that you hear this word pole. And so when we talk about what the pole is, just to be clear here, we're going to refer to the positive x-axis as the polar axis, but we refer to the pole as being this imaginary thing that's sticking out of the origin right here. You can imagine like a pole coming out of the ground here, where there's like a string tied between it, the pole, and the point that we're looking at here. And so we're basically talking about the polar coordinate axis is giving the location of a point in terms of how far away it is from the pole and also how far of a direction angle you have rotated from the polar axis. Okay, and so all of our points are given r theta form. In terms of r and theta here, let's go ahead and look at some of the things over here in this picture. We have 4 points given A, B, C, and D, but what we want to do here is basically in 1 through 10 acknowledge which of these points are represented by these coordinate pairs that you see here. And so the neat thing about the polar coordinate system is there's not just one way to represent a point here, because in terms of r being positive or negative, that's going to give an indication as towards direction. Okay, that we go here. So when we talk about r theta here as being this point, I want you to know that r theta is one possible way of representing this point here, but another way to do this would be to rotate around 180 degrees from where we're starting here and face this direction here, but go a negative r distance, and r being negative means that we walk backwards here. And so another way to look at this is we could say that we're going to go backwards by r, but we're going to be facing theta plus 180 degrees here. Or another way to look at this is we'll go backwards by r, but we're going to face theta plus 180 degrees, or pi radians here. And so this is one way that we can represent a point here, given that we would be facing in the direction that is opposite of theta here, but we would walk backwards by r. Another way to represent a point would be this. We could keep r positive, but if I were to rotate another 360 degrees around, I'd be facing in the same direction. And so as long as I go the same number of units r away from the origin, and I'm facing a coterminal angle, then I would land at the same point as well. And so we could say that r theta plus 360 degrees here is also a valid point, or we could write this as r theta plus 2 pi, depending upon whether we're working in radians or degrees here. And so these are both also considered to be valid ways to get to this point, whereas when you're talking in the xy coordinate system, rectangular coordinate system, there's only one way to get there, and that's to go left or right by an amount x and up or down by an amount y. So looking at these here, excuse me, number one, it just says, hey, 3 comma 225 degrees. Well, imagine that we're talking 3 away from the origin. In terms of which of these points could represent this, they're all 3 away from the origin, but in terms of which one's going in a 225 degree direction here, well, looking at 0 as being on the positive x-axis or the polar axis here, 225 degrees would be this point right here. And so we can see that we're really talking about this point right here, letter C. And so I could throw a C on this, whereas when I look at now, let's see here. Let me write on this here. That's better. When you look at number 2 here, it says let's go 3 units away from the pole, but in a 315 degree direction. We'd say 315 degrees would be down here between 270 and 360, but it'd be this letter D right here. You look at all of these so far as being pretty easy till you get to number 3 here, and 2 things happen. One, R is negative, and the other thing that happens is we've switched into radians. And so 5 pi fourths, remember that 4 pi fourths would be pi here. It would take 4 45 degree rotations or pi fourth rotations to make it over to 180. So 5 pi fourths is actually facing right here in this direction. Now the interesting thing here is this. It says that you're going -3, but in a 5 pi fourths direction. So when you talk about 5 pi fourths is facing this direction, -3 means we actually walk backwards 3 away from that direction here. And so what this means is this is indeed or actually the point A here. Now considering number 4 says, hey, you know what, we're going to go backwards 3, but we're going to face a pi fourths direction. And so knowing that pi fourths is this 45 degree direction along here, it says if I go pi fourths rotation and walk backwards 3, this one actually lands at C. And so the thing here is to keep in mind that points, if R value is positive, you're going to go in the direction of the angle that is given to you. But if R is negative, you're going to go the direction that is opposite of the direction angle that was given to you to begin with. So do me a favor, match out 5 through 10 here and see what you can get those to match with. Cheers.